ask a question at any time and answer at any time. But also, this will be captured on Screencastify, and I will put it as a YouTube video on the Google, on your Google Drive, not your Google Drive, but your Google Classroom. So it will still be like a YouTube video, like I normally would do, but now you can ask questions as we go along. Can everybody hear me okay? Just on mic and say, yeah, I'm good. Everybody hear me okay?
Yep.
Yeah.
Yep.
All right. And if you have any issues as we go along here, once again, you can email me and we can take care of it through email. What we've worked on up till now is we've worked on hypothesis testing and null hypothesis and writing the null and alternate hypothesis. We talked about a one-tailed test. We talked about a two-tailed test, and how we determine if it's a one-tail or a two-tailed test. So we've done all that, all the preliminary stuff. Today what we need to go through is we need to go through how do we do an actual test. And we'll start doing some calculations here. So you'll probably need your calculator here to go through some actual calculations as we go through this. What we have here at the beginning of the notes is you'll be given an alpha value, and we talked about the alpha value. You'll be given an alpha value within the problem. The alpha values are typically 0.1, 0.05, or 0.01. Okay, we have a one-tailed test where we look at a left tail and we look at our right tail on our one-tailed test. Okay, we determined that the other day. And once again, the one-tailed test. This, we look at the alternate hypothesis. When the alternate hypothesis is mu is greater than, we're going to use a right tail test. And when we look at a left tail test, we look at the alternate hypothesis. Mu is going to be less than. And when we have a two-tailed test, our alternate hypothesis will be mu will be not equal to. So that's how we determine, once again, if we have a one-tailed test or a two-tailed test. And we talked about critical values, and these critical values separate you into a critical region or a non-critical region. A critical region is where we reject the null hypothesis. A non-critical region is where we don't reject the null hypothesis. And we'll go through this here as we go along. But we have a critical value that we deal with here. Okay, our critical values are all within this table right here. But you do not have to memorize this table, and this is why I ask you to get out your t-table. If we look at your t-table, if we look at the t-table, along the top, all we've dealt with is we've dealt with a confidence interval. All we've dealt with is a confidence interval. Now, if we look at the next two rows on your t-table, you have a one-tail test and a two-tail test. Okay, you have a one-tail and a two-tail test. Hold on a second. Let me do something here. I can't get it up here. But your one-tail and your two-tail test, you have an alpha value along with the one-tail and two-tail along the front or the top of the table there. That corresponds to the alpha values that we're dealing with here. These are the alpha values that we are dealing with here. We can go across the rows to an alpha value that we need. Now, if we stretch down a column, say we have a one-tail test, an alpha value of 0.10. So let's go to the one-tail test, alpha value of 0.10, which is the second column, and take that all the way down to the bottom. We have a z-value down at the bottom of 1.282. And if we look at our critical value for a left-tail test or a right-tail test, it's our 1.282 or 1.28. So these table values that we have right here are also on your t-table. So you're going to use your t-table to pull off these critical values. And once again, knowing if it's a one-tail test or a two-tail test, a one-tail or two-tail test will allow us to be able to determine with an alpha value what the critical values are. If your z-score falls into a critical region, your conclusion is going to be you reject the null hypothesis. So if your z-value, and we're going to do a z-test value, if our z-score falls into a critical region, you're going to reject the null hypothesis. If your z-score falls into a non-critical region, you're going to fail to reject the null hypothesis. You have two options here when we do our hypothesis testing. We will either reject the null hypothesis or we will fail to reject the null hypothesis. Okay? There's a difference between fail to reject and accept. When we fail to reject the null hypothesis, we still may not believe it's true, but we don't have enough statistical evidence to prove that it is not true. Okay? So we look at this, we fail to reject it, we may not accept it, we just don't have enough information to reject it. So we may have to do a further study. So your solutions are going to be, you're either going to reject the null hypothesis or you're going to fail to reject the null hypothesis. And once again, the null hypothesis may be false, but there's not sufficient evidence to reject it. We have a test value, the z-test value. And we've dealt with this already. We've dealt with this when we talked about our central limit theorem. Our test value, our z-test value is calculated by x bar minus mu divided by standard deviation divided by the square root of n. And we've dealt with this already. We've dealt with our test value, or the formula to be able to calculate a z-score. We have x bar minus mu divided by standard deviation divided by square root of n. If we look at a two-tail, we're still going to be dealing with this bell-shaped curve. When you deal with a two-tail test, you have critical values on both sides. These are going to be your critical values. And once again, these critical values come from the table. They will come from the t-table. Whatever those critical values are. Once again, the z values, we stretch all the way down to the bottom. We will do a test value. And we have two regions here. These are our critical values. This is a non-critical region. This is a non-critical region. The two sides on the outside are critical. So our two sides that are on the outside are critical regions. We'll do a test value. And wherever this test value is, if the z-score falls into a critical region, which is out here, these are critical regions, we will reject the null hypothesis. We will reject the null hypothesis. If we fall into a non-critical region, which is the middle part there, we fail to reject the null hypothesis. Once again, we have two solutions here. We will either reject the null hypothesis or we will fail to reject the null hypothesis. What this looks like on a one-tailed test. I'm just pausing here just to make sure that everybody's caught up. What this looks like on a one-tailed test. We still have our bell-shaped curve. I'm going to do a one-tail left test. What it means to be a left tail or one tail left. It means it's going to be on the left side of our bell-shaped curve. This will be our critical value. It will be on the left side of the curve. If it was a right tail test, it would be over here. That's the only difference. We can still find our critical value from our t-table. Once again, the top will tell us do you have a one-tail or a two-tail test, and what's our alpha value. We drop all the way down to the bottom for a z-test when our sample size, once again, is greater than 30. We'll talk about t-test on Monday. This is a non-critical region, and this is critical. And the same rules apply. If we fall into a non-critical region, we fail to reject the null hypothesis. If we fall into the critical region, we will reject the null hypothesis. And once again, if you do not get everything as we go along here, this will be as a YouTube video. You can always go back to the YouTube video and be able to complete this. Steps that we'll be doing for hypothesis testing. First step, we will state the two hypotheses. Okay, if we identify the claim, sometimes we'll do that, sometimes we won't. But we have to state the null and the alternate hypothesis. And once again, we normally do the alternate hypothesis first. It's what we hope is true. So we're going to state the hypothesis and identify the claim. And once again, the claim, sometimes we'll do, sometimes we won't. The main thing is to get this right here. Get the hypotheses. What's the null? What's the alternate? Alternate, once again, is what we hope is true. Step number 2, find critical values. And when I talk about the critical values, we're looking at the t-table. So we find our critical values from the t-table. Third step, we find our test value. We compute the test value, which is x bar minus mu divided by standard deviation divided by square root of n. So we compute the test value next. Owen Beatty, did you ever make it on here?
Yeah, I'm here.
All right, thanks, Owen. Brandon Zaleski ever make it? Andrew Stitt ever make it? So we compute the test value, x bar minus mu divided by standard deviation divided by square root of n. Step 4, make a decision to reject or fail to reject the null hypothesis. If I fall in the critical region, I will reject the null hypothesis. If I have fallen in the non-critical region, I fail to reject the null hypothesis. And our final step, summarize your results. Once again, just like with the confidence interval, you can make a final statement. At this point, we have enough evidence to reject the null hypothesis of whatever it is, or at this time, we do not have enough evidence to reject the null hypothesis of whatever it is. Let's take a look at a problem. Flip the side. Medical rehab. Education Foundation reports the average cost of rehab for a stroke victim is $24,662. $672. A random sample of 35 stroke victims had an average cost of $25,226 with a standard deviation of 3251. Alpha value 0.01 can be concluded that the average cost of a stroke rehab patient at a particular hospital is different than the 24,672. Once again, we talked about we have an established value. That established value is 24,672. Okay, that is what is established. And what we came down to is a value 25,226 with a standard deviation of 3251. Alpha value 0.01. We want to see if it's different than the 2462 or 24,672. Okay, the key word there is different from the 24,672. So just like we did 2 days ago, and we started, or 3 days ago, whatever it was, Monday, we started writing null and alternate hypothesis. What would be our null and alternate hypothesis here? Because what we want to conclude is the average cost of stroke rehab at a particular hospital different than the 24,672. Okay, so write your null and your alternate hypothesis. Okay, if we take a look at the alternate hypothesis, the alternate hypothesis. What would be our alternate hypothesis here? Kylie, what would be our alternate hypothesis? What do you think?
Not equal to 24,672.
That is correct. Not equal to 24,672. Which means the null then would be the opposite of that, equal to 24,672. So if we take a look at our values, we have mu, what's giving to us is 24,672. We have a sample mean of 25,226. We have a sample standard deviation of 3251. And we have an alpha value of 0.01. Okay, taking a look at our null and alternate hypothesis here. We have equal to and not equal to. Todd, would this be a one-tail or a two-tail test?
Two-tail test.
Two-tail test, because we talk about equal to and not equal to. So we have a two-tail test. So the next thing that we can do is draw our bell-shaped curve. We can put our two tails in here. Which are our critical values. So if we take a look at our t-table, our alpha value, we have a two-tail test, so we're looking at the two tails here. We have an alpha value that is an alpha value that's 0.01. So we're coming over here to the 0.01 alpha value. To find our critical values, we stretch this all the way down to our z value, which is down here at the bottom, 2.576. And once again, if you use 2.58, that is fine, but I'm going to use 2.576. And over here, we have a negative 2.576. Those are our critical values from our table. The next is to calculate our z-test value, which is x bar minus mu divided by standard deviation divided by square root of n. We have an n, let's see how many, we had 35 stroke patients. So putting in our values, we have x bar 25, 226, minus mu, which is 24,672, divided by our standard deviation, 3251, divided by the square root of 35. And now it becomes a clickety-clack exercise. Once again, you can quantify the top and the bottom. Where we have parenthesis 25 to 26 minus 24 672 divided by parenthesis 3251 divided by second square root of 35, and parenthesis and parenthesis. Or you might have to use your right arrow to pull out of the parenthesis. But make sure you quantify the top and the bottom. And hit enter. And what we should get is 1.008, hopefully. So this is our test value. So if I look at my number line, I have 0 here in the middle. 1.008 falls right around here. This is non-critical. This is critical. Critical. We fall into a non-critical region. So if we fall into a non-critical region, we fail to reject the null hypothesis of rehab costs of 24,672. If this was just a one-tail test, you would go along the one-tail column along the top there and drop down to your z-value. Okay, this is hypothesis testing. Now the worksheet that we've been working on, I had you go through and write the null and alternate hypothesis. Then I asked you to go through and just do a one-tail test or a two-tail test for each one of those. Now what you can do is go through and do the problems. Okay, do the actual problems. The steps in regards to what you have to do. To state the hypothesis, you've already done that. What you have to do is go through now, do a bell-shaped curve, find your t-table or your critical values on your t-table, compute your test value, and then state a conclusion. Okay, on Monday we will pick up from here and we'll deal with a t-test. But what you can do now is the worksheet. You can complete the worksheet that you've been working on for the past week in regards to null and alternate hypothesis. You can go through and do the computations. I've also posted the solutions to that, so you can refer to that. If you have any questions, feel free to email me. If you want to stick on for an extra minute and ask me a question, that would be fine. But other than that, that's all I have for you today. Your homework, once again, is to complete the worksheet that we have there and check your solutions with regards to what's on Classroom already. Solutions have been posted there. Thank you for attending today. Appreciate you coming to class today. I wish I was actually in class, but we will make the best of what we are dealing with here. Once again, if you have any questions, you can stick around. I have another extra 5-10 minutes before my next class starts. You can ask that. If not, I is done. Have a good weekend. Stay safe. Stay out of trouble. And adios. See y'all.